Hi, today we're going to be talking about perpendicular and angle bisectors. So first we're going to be talking about the perpendicular bisector theorem. This right here is a line segment. Now you might be asking, what's a perpendicular bisector? A perpendicular bisector is a line or line segment that goes through the midpoint at a 90-degree angle. So, if a point is on the perpendicular bisector of a segment, then it is equidistant or the same distance from the endpoints of the segment. So to explain, this point right here is the same distance from A as it is from B. Now let's talk about the angle bisector theorem, and for that we need an angle. This angle is ABC. An angle bisector is a ray that bisects, or cuts in two, an angle into two equal angles. So in this case, ABC has been cut into two equal angles. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So as you can see right now, that is the same distance. But technically, we don't know if it's on a bisector yet until this. The line from the angle bisector to the sides must be perpendicular. So now let's talk about perpendicular bisectors in triangles. In a triangle, the perpendicular bisectors at the sides of the triangle meet at a point called the circumcenter. That is right here. This is our circumcenter. The circumcenter is equidistant to the three vertices. So this point is the same distance from here as it is from here and here. Now you might be noticing that I'm calling it a center, and it's the same distance from three different points, kind of like the center of a circle is the same distance from every point on the circle through a radius. That's because the circumcenter is the center of the triangle's circumscribed circle. Now that's a lot of circa that you're hearing. Circumcenter, circumscribed, circle. So I want to make sure you understand. A circle that contains all the vertices, so like this point, this one, and this one, of a polygon is circumscribed about the polygon. Now let's talk a little bit more about circumcenters. This first one is an acute triangle. And when it's an acute triangle, the circumcenter is in the center. But let's see what happens when we have a right triangle. So as you can already begin to see, when we have a right triangle, the circumcenter is actually at the midpoint of the hypotenuse. Finally, when we have an obtuse triangle like this one, look what happens to the center. The center actually goes outside of the triangle. So the circumcenter in an acute is inside. On a right, it's on the hypotenuse. And on an obtuse, it's outside of the triangle, past the longest side. So, now let's talk about angle bisectors. In a triangle, the angle bisectors of the triangle meet at a point that we call the incenter. That would be right here. The incenter is equidistant to all three sides of the triangle. The incenter is the center of the triangle's inscribed circle. Now, a circle inscribed in a polygon intersects with each line that contains a side of the polygon at exactly one point. So now we're going to write an equation in point-slope form for the perpendicular bisector of the segment with the given endpoints. In this case, our endpoints are L is 4, 0, and M is negative 2, 3. So the first thing that we have to do in this case is find the midpoint. So the way that we find the midpoint is we use our midpoint formula. So what that is we add our two x values together. So 4 plus negative 2, or 4 minus 2. And then we add our two y values together. 0 plus 3. So at that point, 4 minus 2 is 2, divided by 2 is 1. And 0 plus 3 divided by 2 is 1.5. So that's our midpoint. Our second step is to find the perpendicular slope. So remember, for that we do y2 minus y1 over x2 minus x1. So 3 minus 0 over negative 2 minus 4, which becomes 3 over negative 6, or negative 1/2. But then, to make it perpendicular, we have to find the opposite reciprocal, which means negative 1/2 becomes positive 2. So now that we have a midpoint, which is the point that we know goes through a perpendicular bisector, and we have the perpendicular slope, meaning we actually know the slope of the perpendicular bisector, we can write the equation in point slope by plugging it in. So the way that we do this is we write it in and we go y minus, in this case, the y value was 1.5, equals the slope times x minus the x value, which was 1. And there you go. That's our slope. And that's how you do that. If you have any questions, please feel free to comment. Feel free to like, subscribe, all that jazz. Thank you very much.